Now let's take the next topic, which is probability. What is probability? We really have a good idea of what probability is, right? It's simply the chance that something may happen. Now, there is really an easy way to explain probability. Practically everyone uses it. All you have to do is flip a coin. There is 1/2 chance of the coin facing head up. So, the probability of getting a head up on the coin is 50% or half. Now, why learn about probability? By learning about probability, we will be able to find the probability or the chance that an event can happen. Now, how to solve sums on probability? Probability can be defined as number of favorable or desirable outcomes upon total number of outcomes. Example, if a die is rolled, find the probability of getting 2 on the die. Here, the desirable or the favorable outcome is getting 2 on the die. That is one possibility. Now, the total number of outcomes are, we can have any numbers from 1 to 6. So, there are 6 outcomes. So, probability of getting 2 on the die will be number of favorable outcomes upon total number of outcomes, that is 1/6. Now, before moving ahead to actually solve the problems on this topic, let us understand some terms used in probability. Experiment. In statistics, whenever we do a research, it is called experiment. Then we have equally likely outcomes. 2 outcomes are called equally likely if both of them have an equal chance of happening. Example, when a die is rolled, all the 6 numbers on the die have an equal chance of occurring, so they are called equally likely outcomes. We have sample space. The set of all possible outcomes of an experiment forms the sample space. Example, when an unbiased die is rolled, then the outcomes are any numbers from 1 to 6. So, the sample space will be all numbers from 1 to 6. That can be written as S is equal to 1, 2, 3, 4, 5, 6. Now, we have an event. Each possible outcome of an experiment is called an event. Now, we've already seen what do we mean by probability. It's simply the chance that something may happen. We have 2 types of probability. The first one is empirical probability. The probability based on an actual experiment is called the empirical or the experimental probability. Let's take an example here. If a coin is tossed 10 times and we get 6 heads and 4 tails, then the probability of heads occurring is 6/10 and tails occurring is 4/10. Now let's take the second type of probability, that is classical probability. The probability obtained without repeating the experiment to get the actual probability is called the classical probability. Now we can write this as probability is equal to number of desired or favorable outcomes upon number of possible outcomes. Now take an example here. If a coin is tossed, then there is an equal chance of getting heads or tails. The prerequisites for this topic are, you need to know what are even numbers, what are odd numbers, prime numbers, perfect squares, then multiples of some numbers. Quite elementary. Now let's take the problems based on this topic. We take the first one. An unbiased die is thrown. What is the probability of getting an even number, a multiple of 3, an even number or a multiple of 3, and an even number and a multiple of 3? Now in this case, whenever an unbiased die is thrown, the number of possible outcomes could be any numbers from 1 to 6. That is, there are 6 outcomes which are possible. Now in the first part, we are told to find the probability of getting an even number. When can we get an even number? On the die, if the numbers shown are 2, 4 or 6, we get an even number. So the number of possible outcomes for this would be 3 outcomes. So the required probability is number of favorable outcomes upon number of possible outcomes, that is 3 upon 6, which is equal to half. Now in the second part, we want to find the probability of getting a multiple of 3. So we have the desired outcomes as 3 or 6 because we need multiples of 3. So that could be either 3 or 6. So there are 2 desired outcomes and the number of possible outcomes is 6. So the required probability would be 2 upon 6, that is 1 upon 3. Now in the third part, we want to get even number or a multiple of 3. So the desired outcomes could be 2, 4, 6 or 3 or 6. That is, we could have the desired numbers as 2, 3, 4 and 6. How many desired outcomes do we have? We have 4 desired outcomes and the number of possible outcomes are 6. So here the probability would be 4 upon 6, that is 2 upon 3. Now in the fourth part, we want an even number and a multiple of 3. So here the desired outcome could be only 6. That is, the number of desired outcome is 1 and the number of possible outcomes is 6. So the probability of getting an even number and a multiple of 3 is 1 upon 6. Now let's take our next problem. What is the probability that a number selected from the numbers 1, 2, 3 and so on up to 25 is a prime number? Now here we are taking numbers from 1 to 25. The number of possible outcomes would be obviously 25. Now let's see what are the prime numbers between 1 to 25. They would be 2, 3, 5, 7, 11, 13, 17, 19 and 23. That is 9 possible outcomes. So we have number of desired outcomes as 9. So the probability of getting a prime number is number of desired outcomes upon number of possible outcomes, that is 9 upon 25. Now let's look at our next problem. Tickets numbered from 1 to 20 are mixed together and then a ticket is drawn at random. What is the probability that the ticket has a number which is a multiple of 3 or a multiple of 7? Now here we are taking the tickets from 1 to 20. That is, there are 20 possible outcomes. Now we want a multiple of 3. So the possible outcomes here are 3, 6, 9, 12, 15 and 18. We also want a multiple of 7. So the possible outcomes are 7 and 14. So we have the total number of favorable outcomes as 3, 6, 7, 9, 12, 14, 15 and 18. That is, there are 8 favorable outcomes. So the probability of getting a number which is a multiple of 3 or 7 is number of favorable outcomes upon number of possible outcomes, that is 8 upon 20. We simplify this further to get 2 upon 5. So the required probability is 2 upon 5. Now before moving ahead to the next problem, let's understand the concept of cards. We are talking about playing cards. I think you all must have played cards some way or the other. Now let's see about the pack of cards. In a pack of cards, there are 52 cards and there are 4 suites, which are club, spades, diamonds and hearts. There are 13 cards of each suite. Then there are 4 aces, 4 kings, 4 queens, 4 jacks, 4 tens and so on. That is, there are 4 cards of each number. Then there will be 26 black cards and 26 red cards. Now with this in our mind, let's start with the next problem. One card is drawn from a well-shuffled pack of 52 cards. Find the probability that the card drawn is an ace card, is a red card, is not a red card, either red or king. Now let's take the first one. We want the probability of getting an ace card. Now in this case, there are 4 aces in each pack, that is 1 ace of each suite. Thus, there are 4 possible ways. So, the probability of getting an ace card is 4 upon 52. We simplify this to get 1 upon 13. Now, we want the probability of getting a red card. Now, we know that from 52 cards, there are 26 red cards. So, the probability of getting a red card would be 26 upon 52, that is nothing but 1 by 2. Now we want to find the probability of not a red card. Not a red card means a black card. So probability of getting not a red card would be 26 upon 52, that is again 1 upon 2. Now we want the probability either red or a king. Now total red cards are 26 and number of kings are 4, out of which 2 are red and 2 are black. So we could have 2 kings which are not red. So the number of favorable outcomes here would be 26 plus 2, that is 28. And the number of possible outcomes are 52 obviously. So we get the probability of either a red or a king card as 28 upon 52. Simplify this to get 7 upon 13. Now let's consider our next problem. The king, queen and jack of clubs is removed from a deck of 52 playing cards which are well shuffled. One card is selected from the remaining cards. Find the probability of getting heart, a king, a club, the 10 of hearts. Now, number of cards remaining would be 52 minus 3, that is 49. One card can be selected in 49 ways. Now, in the first part, we want to find the probability of getting a heart card. Now, number of heart cards are 13. So, the probability of getting a heart card is 13 upon 49. Now, in the second part, to find the probability of getting a king. Now, in our case, the king of club has already been removed. So, how many kings are left? There are 3 kings left. So, the probability of getting a king would be 3 upon 49. Now, in the third part, to find the probability of getting a club. Now, from the club cards, 3 cards have been removed. And we know there are 13 club cards in a pack of 52 cards. So, the number of club cards left are 13 minus 3, that is 10. So, the probability of getting a club card would be 10 upon 49. Now, in the fourth part, to find the probability of getting the 10 of hearts. The 10 of hearts can be obtained only in one way. So, the probability of getting the 10 of hearts is 1 upon 49.